Luke told me, he arrived this morning, so we didn't have a chance to talk yesterday night, but he told me he was going to be the opposite of Bart, and they know each other very good. So I trust that they told me the truth. They both wrote a lot of articles about the subjects they lecture about. They wrote books, and they both, that's very important, I forgot to tell you, are the editor-in-chief of the Fire Safety Journal. And that's where you both put all your articles in, I hope, or not.
But of course, there can only really be one person in charge.
Oh, one person in charge. So there's going to be a fight later on during lunch. So you also get 45 minutes. And because of Bart, we go to lunch a little bit later. So don't worry about it. And I'll give you a sign. And then please feel free to talk about your presentation. And ladies and gentlemen, it's about sociological issues in fire safety, which for me is very interesting because I have a social science background. So I'm really interested in this. Good. Yes, you are in trouble now.
Okay. No pressure though. Thank you for that. Yeah, no, it's an absolute pleasure to be here. I've been here once before. The previous time I came, I was speaking about something that I actually can claim some expertise in. This topic is one that I'm much more uncomfortable talking about for a variety of reasons that I'll mention as I go through. But the title is Sociological Issues in Fire Safety Regulation. And the request to give this talk, I think, was based on a paper that I published with a colleague, Graham Spinardi, who's a sociologist who works at Edinburgh, and Jose Torrero, who works at the University of Maryland some years ago. And I'll explain sort of what that was and how that happened as I go through. I work at the University of Edinburgh. I am a lapsed structural engineer. If there are any lapsed Catholics in the room, you'll know what I mean. I kind of lapsed into a fire safety person, although I would never claim to be a fire safety engineer because I am profoundly aware of my incompetencies. And it's very important for me to say that, particularly when talking about these issues, as you'll see as I go through. So I shouldn't really be the speaker, to be perfectly honest. The speaker should really be the chap on the right. That's Graham Spinardi. He works at the University of Edinburgh. He is a science and technology studies sociologist, one of the cleverest and most insightful people that I've ever met. And he did most of the thinking behind the work that I'm presenting today. On the left, you have Sir Duncan Michael, and he's the person who forced me into being interested in these issues in the first place when he was chairman of the Ove Arup Foundation in London, and realized at some point that it would potentially be useful if he got the Ove Arup Foundation and the Royal Academy of Engineering to co-sponsor Graham's existence within my research group for 5 years, fully funded, to basically study us and see what falls out. And this paper is the result, in part, of that. So the paper that I think caused, and it did cause a bit of a fuss, this paper, when it was published in 2016, was called A Review of Sociological Issues in Fire Safety Regulation. You can see the authors there. Basically what it was Graham Spinardi, who's a science and technology studies specialist whose background is in studying missile defense, actually, has quite a reputation in the missile defense field, if you're interested in that field. And got interested in fire safety, and Jose Torrero, who many of you will know, has a long history and is one of the most respected people who works within the fire safety community, certainly within the academic community. And then me in the middle as a referee, to the extent that I was able to be a referee. And this paper fell out after several years of discussion and agonizing. And it caused quite a lot of discomfort, I think it's fair to say, within the fire safety community back in the summer of 2016, and we came under quite a lot of criticism, it has to be said, for some of the things that we had said in this paper. And this is sort of a statement that I just pulled from the abstract. So the overarching objective of the paper was to argue that the fire safety professions ought to be more reflexive, by which I mean we ought to reflect more. We ought to act without thinking more, which is what some people take the word reflexive to mean. Bad choice of words, admittedly. And informed about the nature of knowledge and expertise that they develop and apply. And I was quite surprised to learn there's an entire community of sociologists who study the sociology of technical knowledge and how people apply technical knowledge. And also to suggest that fire safety scientists and engineers, the people who are in this room, as well as practitioners, ought to actively collaborate with social scientists in research designed to study the way that people interact with fire safety technology, by which I do not simply mean people who study human behavior in fire, by which I also mean the way in which people in this room interact with fire safety technology, and in particular, interact with fire safety knowledge and fire safety regulation. And we've subsequently become very interested in fire safety regulation. A couple of quick disclaimers. My intent is to open up conversations rather than to criticize. It's very important for me to say that. A lot of what I'm going to say today might sound critical. That is not intended. My intention is I think it's very important that we discuss these issues. And my focus is admittedly UK-centric. Actually, I would say English-speaking world-centric, because those are the communities that I've had most of my exposure to. I'm actually a Canadian, if you're wondering where this kind of slightly odd Scottish, English, Canadian accent is actually from. I'm not South African, which I tend to get occasionally. But the ideas that I'm going to present hopefully are universal. And to be perfectly honest, I have absolutely no idea in practical terms how fire safety is regulated in the Netherlands. So it would be foolish for me to attempt to tell you what you probably know much better than I do. But I hope that some of the themes that come out of this talk will be useful as conversation starters within this community. So, a quick introduction. Fire safety science and engineering has advanced, and I should point out actually, from about this point on, what I'm actually going to do is read the paper. So what I've done is I've taken the paper, and I should point out the paper is 38 pages of text without a single figure. So I can't promise any. It was a foolhardy thing that I agreed to do here, to be honest. And I can't promise to show you fancy CFD simulations like Bart. I always like sharing a stage with Bart, although I prefer to be up first, to be perfectly honest. So fire safety science and engineering has advanced enormously in recent decades. That is evident through the proceedings of these workshops, if nowhere else. You can go back and look at the presentations that have been given over the years. And if you're in doubt, you can look at the presentation that Bart just gave. The ability of fire safety scientists and engineers to make predictive analyses of fire phenomena is extraordinary. And there's no question about that. Design innovation continues to push the boundaries and question the limits of prescriptive design guidance or rules-based design guidance. And if you want evidence of that, you need only look at the City of London and recognize that most of these buildings in the City of London have been heavily fire engineered by very clever people using very clever analyses. Fire deaths have also mostly seen a steady decline. So these are statistics up to, 2007. And you can see a steady decline in various parts of the world in fire statistics. And that trend is generally continuing, although sort of leveling out a bit in more recent years. And so we might think, okay, well, all's best in the best of worlds then. And there's nothing we really need to worry about that much. But when we showed this information to Graham Spinardi, a science technology studies specialist, he asked a whole load of questions. And this is just a few of the questions that he asked. And these questions I will ask rhetorically. Do fire safety solutions take sufficient account of social context? Can we develop better ways to learn and apply the lessons of fire disasters in particular? And also, as I'm going through this, it's probably worth remembering the date this paper was published in the summer of 2016. Do the fire safety professions truly understand and thus deliver on society's expectations with respect to fire safety? Do all stakeholders have sufficient understanding of the fundamentals, the stuff that Bart was talking about, of fire safety, to underpin a regulatory shift towards performance-based design, which seems to be happening everywhere you look these days? Can fire safety be rigorously quantified in engineering terms? What do we mean by safety? Are current practices increasing risk or conversely leading to excessive and expensive fire safety measures? And by current practices, I would mean a more prescriptive approach to fire safety. And what can be done to enhance the development and uptake of fire safety science to further promote best practice across all the relevant fields of fire safety engineering? So these are the types of questions that we were asking. And we actually held a large workshop with a number of international participants, and we talked through all of these questions. And the paper that I put up is what fell out. So what I'd like to do now is sort of go through essentially what the rest of the paper says. And to be perfectly honest, at this point, I could just have speaker notes and not show you any slides. So the reason I've made the slides, and they're being put up here, is so that you guys have a record of what I would say if you can't be bothered to read 38 pages without a single figure in it, which I wouldn't blame you for at all, although the paper does have additional depth of insight, I like to think. But the classic fire safety community response to the situation that we find ourselves in trying to answer all of these questions, from people like me, who are fire safety science engineers, is more scientific and technical research funding, please. And you'll always hear people like me say, we need more funding, we need more research, we need more information, we need to know more and more and more and more in depth about the physics and the chemistry. And I'm not saying that we don't, but what if the existing knowledge isn't being properly exploited? We have all this knowledge. What if even the knowledge we have isn't being properly exploited? What if fire safety research fails to lead to real progress, by which I mean fails to lead to better fire safety outcomes across the populations of people that we're interested in? Is it legitimate for me to be asking for more scientific and technical research funding? Is it worth considering the possibility that making additional progress in fire safety might depend, at least in part, on a deeper understanding of the social nature and the social context of fire problems? Now, obviously, I'm up here speaking about this, so it's obvious what I think the answer to that question is, although I should say as a technical person primarily. So the result of that is this talk, which is a talk in 3 parts. First, fire in society, which is the most obvious stuff. Then some comments on regulation. And then some comments on the way we generate and apply fire safety knowledge as a community of fire safety professionals. And the asterisk there, it says, with very boring slides underneath. So, and that is the truth. I promise you that. It's the slides, honestly, it's just a written record of what I've said, and speaker notes for me, because there's a lot of ideas in here, and if I try to do this ad lib, which would be my normal approach, I will miss important points, which is something that I don't want to do, because I do think all of the points are very important. So the first part, fire in society, this is the most obvious aspect. So this is the fact that poor people are more likely to be injured or die in fires. And that's true around the world, and that should be no surprise to anybody who works in fire safety. So in most cases, human behavior remains central to both fire initiation and to outcomes. Socioeconomic circumstances play a large role in those outcomes. For example, most fire deaths we know occur in domestic dwellings, typically around 80% in most jurisdictions in the developed world. Rates of fires and casualties are strongly correlated with socioeconomic status. There's been lots of work over the years. There are references in the paper to back that statement up. Fire deaths are generally decreasing in Europe, North America, and many or some other jurisdictions. Just to give you some numbers here, some comparative numbers, which I think are actually very useful to think about. As someone who is demanding more government funding for research. In the UK, in 2013-14, there were 322 fire-related deaths. That was the lowest figure that had been experienced for more than 50 years. 80% of those were due to fires in dwellings, so not the fancy buildings in the City of London that I use my clever structural engineering skills on. And dwelling fires are known to be proportionately more fatal than fires in other types of buildings. For comparison, there were almost 2,000 road traffic accident deaths in the UK in the same year. So these are the comparative terms. When you're demanding government funding, I think it's important to be aware of the statistics like this. Non-fatal fire casualties have seen a similar reduction in recent decades. And we've also seen that simple and inexpensive solutions can be very, very effective at ameliorating these statistics with respect to fire deaths. So some examples, smoke alarms. Lots of statistics out there that says that early detection approximately halves the chances of death if you're in a building that has a fire. So if you find out early, you're about half as likely to be killed by the fire. Cooking appliances are the largest cause of dwelling fires in the UK. Although they only account for 10% of the fatalities, and that's because people in general are aware whilst they're cooking. I wonder about the people that aren't aware whilst they're cooking, to be perfectly honest. And in the UK, there's lots of work that suggests that a lot of kitchen fire reductions are due to the fact that people stopped cooking French fries in pans of oil with the introduction of ready-made oven chips that you can just stick on a baking sheet. And there's actually a lot of data to support that claim. And more than 1/3 of UK fire deaths in dwellings are attributed to cigarettes. So if we just prevented cigarettes, we could actually go a long way to solving many of the fire safety problems that we have in terms of reducing death. So these are important things for us to think about as technical people when we're demanding that we understand better various aspects of the physics and the chemistry. And all of those above factors, the smoke alarms, the uptake of smoke alarms, the way people cook their meals, whether or not people are inclined to smoke cigarettes, are all strongly influenced by socioeconomic factors. So we could draw correlations between all of those causal factors and socioeconomic status. If you look at the US data, there's lots of data that says, based on the US Census, that if you live in a low average income area, your fire risk is much higher. And I won't dwell on that, other than to say that one of the reasons for that is arson. Arson is clearly a social issue, and in particular, arson in the context of young people is clearly a social issue. So these are the obvious aspects of sociology of fire safety engineering. Hopefully nothing I'm saying is a surprise to anybody in the room. What might surprise you, and this is not in the paper, this is the one slide in this talk that is actually not in the paper, is recently at Edinburgh we've been working on fire safety in informal settlements and refugee settings, or increasingly doing work in this area. And just to give you some statistics, in the world, if you look at global fire statistics, you're looking at, depending on who's estimating, anywhere between 180,000 and 300,000 people per year are killed in fires, in unwanted fires. 95% of those deaths are in low and middle income countries. In the UK, 0.31 fire deaths per 100,000 people a year. In Côte d'Ivoire, 14.32 per 100,000 people per year. In terms of disabilities, fire is the leading cause of morbidity globally. And there are 10 million disability-adjusted life years lost globally each year as a consequence of injuries related to fire, predominantly in the developing world. These statistics are shocking in the context of the discussions we tend to have in the Western world. And in terms of costs, the costs of fire globally, 1% of global GDP, that's about 800 billion US dollars, or the entire GDP of the Netherlands. Or about half the GDP of the 1.06 billion people who live in sub-Saharan Africa, to put it in context for you. Now, so I'm not going to talk anymore about that, but I had to put this slide in because these numbers are frankly shocking. If you're interested in it, talk to me, because we are doing some work at Edinburgh now in this area, along with a number of colleagues internationally. So how should fire safety engineers think about these ideas that I just put up? And one of the ways we could think about it is to say, well, those are social problems. That's not my business. I'm a technical person. I'm not going to worry about it. I'm going to let sociologists worry about this problem. And my view is that would be a dereliction of duty. To suggest that these socioeconomic fire safety issues should be considered social rather than technical, as they're clearly linked. Technical solutions cannot make people behave better on their own, but they could ameliorate the outcomes of people behaving badly. Can anybody in the room actually think of an example of a technical solution that cannot make people behave better, but they could ameliorate the outcomes of people behaving badly in a fire context? There's one that I think is plainly obvious. Yeah, domestic sprinklers is a good one. I was going to go for self-closing fire doors, but yeah, I mean, the same general idea, right? But then if we do think about things like fire, the reason I like fire doors in particular is because I don't think that it is a surprise to find out that in many social housing contexts, fire doors are inoperative. And yet we continue to design social housing contexts with fire doors with self-closers. So one has to ask the question whether or not our ignorance of the social factors is justified or morally credible, in my opinion. Anyway, in practice, tackling the social stratification of fire risks might actually be more a matter of political will, economic priorities, and good governance than devising new technical solutions. And I think that's worth thinking about as technical people. It's also worth realizing that societal perceptions of risk are complex. We've seen that in spades in the last couple of years. And fickle. They can change very quickly if something happens. And many factors influence how people view risks and the extent to which they act to mitigate them. So risk perception, again, there's an entire community of psychologists who work in risk perception. And if you're interested in it, I encourage you to read about it. It will make your head spin, the way people evaluate different risks. And as kind of a call to arms, it would be great if we could have better fire statistics so that we could understand all of this stuff a lot better. And that would help us with evidence-based decision-making. Although even then, evidence-based decision-making doesn't always work in the face of political pressure. A good example being a BRE study that was commissioned by the Building Research Establishment, is sort of a UK research agency that deals with fire safety, and they were commissioned by the Welsh government to evaluate the cost-effectiveness of domestic sprinkler installation in Wales. And they created a report that said, fitting sprinklers in all new residential premises in Wales is not cost effective, and the Welsh government then made fitting sprinklers in residential premises in Wales mandatory. So, I mean, we can ignore that as technical people, but I think we're much better off if we understand it and try to operate within that space. The second thing I want to talk about is about regulation, fire safety regulation, which I think is a really timely thing to be thinking about and talking about. I want to talk first about regulation by rules, by prescription. So a key factor in reducing fire risk in society's capacity to regulate building activities to reduce fire-related risks is this prescriptive regulation. These regulations, and again, I could go on for 45 hours, but I won't, about prescriptive rules and where they come from, and I could tell you very interesting anecdotes about where some of these rules come from historically, all of which are shocking and in many cases funny if they weren't true. But regulations have emerged as piecemeal responses to particular fire disasters in many cases. So a disaster happens, there's a knee-jerk reaction by society, the politicians do something about it, and we end up with some new prescriptive rules that we must follow or else. They're built up over decades or centuries, and they go into these necessarily approximate building codes that prescribe rules based on various aspects of the building. So a good example is the requirement that brick or stone should be the main building materials used in London after 1666, which is still there in the building codes, not in the exact rules used by King Charles, but the ideas are still there when we talk about large-scale conflagrations in urban environments. So many of these regulations that come from these fire disasters still persist in some form, despite now being used in circumstances that they might no longer pertain to. My favorite one in the UK context, which Karen will recognize, is the safe evacuation time of 2.5 minutes based on a theatre fire in Edinburgh in the early 1900s, which is nonsensical in many ways. The insulation criterion and standard fire resistance tests, so if you test a fire door or a fire separating wall, the unexposed side of that wall can only reach a certain temperature. You probably happily run your test, and if you get that, you meet that requirement, and you get your fire resistance rating of 90 minutes, you're happy, and you go off and you sell your 90-minute fire doors. But I wonder if you've ever asked where that temperature of 140 or 180 degrees Celsius actually comes from. And the answer is, seems to be that nobody knows for sure. Although there are some papers that outline various plausible explanations for those temperatures, which are now, in many contexts, could be considered historically irrelevant, largely due to industrial storage of cotton wastes and things like that. So we have these prescriptive rules. These rules have taken the form of common sense solutions lacking any detailed scientific understanding. Other times, we have actually made regulatory changes and implemented rules based on detailed technical study. In the UK context, I could point to Piper Alpha as having significant outcomes in the regulatory environment. The King's Cross fire in London, significant changes in the regulatory environment. The Buncefield explosion. All have had in-depth analysis by panels of experts, and all of which have resulted in changes to regulation. So it doesn't have to be historical and rules-based, but it tends to be over time. Prescriptive codes appear, these prescriptive codes that we have, they appear to have served society well in reducing fire damage, deaths, and injuries, because the fire statistics tell us that we're actually doing quite well when it comes to fire deaths and injuries. However, with a clear focus on life safety, I think we don't at all do a very good job of looking at the economic costs or the resilience of our designs in the face of fire. So what happens after a fire? From an economic perspective, I think we still ignore that by and large, and certainly most prescriptive building regulations around the world completely ignore the indirect costs associated with fire. So again, you might think, well, okay, that's fine. Let's talk about societal interests and how regulation happens. So the impetus for regulation, the reason we have a regulation driven by major fires, this doesn't occur in a social vacuum. So for technical people to say, I have a major fire, I understand it, I change the regulations, and this all occurs within a social vacuum that is influenced by politics would be naive and totally ineffective, to be perfectly honest. So our responses, society's responses to fire disasters are mediated by politics and complicated in most cases by the fact that it's hard to do a retrospective analysis because we tend not to have the data that we would want. My favorite historical example of this is that everybody's heard of the San Francisco, the Great Fire of San Francisco, which followed an earthquake. And following the 1906 earthquake, there was this massive fire. And there was a concerted political campaign to emphasize the fire rather than the earthquake. Now, why would the San Francisco government want to emphasize the fire rather than the earthquake? They claimed it was primarily a fire disaster because fires are deemed to be preventable. Earthquakes are not preventable. So if your interests are in economic development of your city, you want to tag this disaster with the preventable disaster as opposed to the unpreventable one, because that will affect the economic situation for your city. And there was a concerted campaign documented, you can go back and look at the documentation, that shows that this was the case. One of the consequences of that is that the fire service got put in charge of the response to the fire rather than updating, for instance, the seismic regulations in and around San Francisco. So the response is in many ways an ineffectual one on the basis of political pressures related to economic development in San Francisco. Now that's one specific example, but you can imagine those types of ways of thinking playing out in any context related to a disaster, whether fire-related or not. So given their important role, the fire and rescue services over time have become established as a de facto source of expertise, and it's important to recognize the role of the fire services in the consciousness of society as de facto experts. In many cases, actual experts, in some cases not, but as de facto experts in the eyes of society, as well as an important lobbying power, I think it's fair to say. The fire safety industry also is a significant social group. They have significant interests in influencing fire safety regulation, and these interests are not entirely benign in all cases when sitting on code committees. I think we just have to be open about that. And I frankly don't blame them for it, because corporations are meant to make money, aren't they? So where does our ability to use prescription to achieve the outcomes that we want end? So they've generally served societies well. They impose specific requirements on fire safety measures that are deemed to satisfy social requirements for safety. So they are deemed to satisfy societal requirements for fire safety, but we do not rigorously quantify society's requirements for fire safety via a prescriptive method, typically. They are necessarily accompanied by very coarse, in most cases, approximations and large margins of safety, and they tend to make limited use of scientific understanding. I don't think any of those statements are particularly unfair of prescriptive regulation. And the very success of prescriptive codes in reducing fire deaths and preventing the number of fires that we actually experience actually undermines the approach we've used to develop them historically over time. Because if we don't have fires, we can't learn things, and we can't tweak as the environment changes with us. So there is, if you like, a black swan of unknown sitting behind the use of prescriptive regulations in a built environment that is constantly evolving. So real fires provide the most authentic feedback. If we don't have fires, we can't get that feedback, so we can't identify design weaknesses or weaknesses introduced by innovations. Another call to arms that I would make is it would be great if we had an international industry-wide approach to coordinate learning from all major fires. The seismic community do this. There are teams of seismic structural engineers when there's a major earthquake who, with funding from the insurance industry mostly, fly to the site of that earthquake, do surveys of building performance, write detailed reports of how buildings performed, and feed that back openly to the structural engineering industry. In the fire safety community, we do nothing of the sort, and it would be great if we could, although I recognize there are significant differences, mostly associated with liability, that might prevent that from happening. And aside from those issues, using prescriptive codes has attracted criticism, and this has moved the world towards a more performance-based approach. So unthinking use in particular, blind following of rules, makes buildings more expensive than they might otherwise be. It's less responsive to changing circumstances and innovations in the built environment, and it can be inflexible as regards specific design situations. And hence, political and commercial influences have sought to apply increasing fire safety knowledge, i.e. performance-based fire safety engineering design, in the interests of deregulation. So there's been or rather, deregulation is perhaps unfair, a move towards functionally based building regulation, which is not constrained by specific rules, but is rather constrained by outcomes with respect to fire safety. So we've got this shift to performance-based or functional-based building regulations that seems to be occurring almost everywhere you look these days. And this introduces significant challenges. So the claim is that if fire safety solutions can be designed and assessed according to the latest knowledge, rather than required to meet historic prescriptive rules that may or may not make sense, buildings can be more innovative, they can be more functional, they can be more sustainable, and they can be safer. Safety levels can be established rather than deemed, so we can actually say how safe a building is. Whether society wants us to do that, I think, is a very interesting secondary question, or whether society can tell us how safe they want the building to be, I think, is an interesting question. Although, incidentally, fire safety engineers are not the only ones who wrestle with this. Structural engineers wrestle with this every day and have codified their levels of safety quite intentionally. And tolerances can be judged more finely, and we can remove unnecessary margins of safety. But this raises important questions about the extent to which fire safety knowledge is understood by all of those involved in the design, construction, operation, and management processes. I think that is a really important question. Where responsibility for regulation and oversight of fire safety actually lies, I think that is a really important conversation and question. How the fire safety community understands and quantifies the acceptable level of fire safety or fire hazard, I think, is a really important question that we tend to gloss over. So many people have commented on various aspects of the points that I just put up, and there's a whole body of literature that you could go to, much of which is referenced in the full paper, that talks about the benefits and pitfalls of various performance-based design approaches to fire safety. In prescriptive regulatory environments, it's worth recognizing that the approval depends on adjudication by the authority having jurisdiction, who will interpret the applicability and the intentions of the rules and tell you whether or not your building is okay. Judgment is sometimes necessary with regarding specific rules, and that has led to the creation of code consultants. Now, in the UK context, the code consultant is not quite so common, but in the Canadian context, where I come from, okay, code consultants are very common. And social relations matter in an approvals process like this, because different individuals might take a different view of the same regulation, because good relationships and trust help to grease the wheels of the relationships that might come up in the industry, and because these long-standing relationships might lead to projects being approved more easily. And it's important to recognize openly these issues about the way we regulate fire safety. In performance-based regulatory approaches, approvers are required not just to adjudicate, but also to understand. And that's the critical difference fire safety knowledge claims. Being expert in application of the rules is necessary, but no longer sufficient. Being expert in the underlying science is now essential for the AHJ. And that is a fundamental difference in these two approaches, which I think is not recognized enough. So are these traditional approval authorities for fire safety sufficiently expert in the fundamentals of fire safety science and engineering? Can they provide the necessary oversight? Who is deemed, and perhaps even more importantly, who is certified as competent within this regulatory process? So one possible solution would be to replace this external regulation, so we don't have AHJs anymore. We self-regulate as a profession. We could do like aviation does, where you have these designated engineering representatives within companies. And that works in aerospace because the manufacturers like Boeing and Airbus, they have a massively high reputational stake, and because failures are really easy to spot when they happen. Having flown here this morning, I was thinking about this as I was working on this slide in the airplane this morning. In structural engineering, my original field, we have, in this field, structural engineers aren't typically subject to detailed regulatory checks of their designs. They are assessed as individuals, and we are trusted as competent professionals. Thus, it is the people who are regulated in structural engineering, not the products. So effective self-regulation in that context is based on accreditation of individuals, which is based on education and experience, and in some jurisdictions, a requirement for ongoing continuing professional development, and in some other jurisdictions, additionally, some spot auditing of the work produced to make sure that you're keeping up with your capabilities. So would either of those work in fire safety engineering? Currently, the focus of regulation is on the quality of the projects. So your building gets approval. You do not get approval. And that is fundamentally different than those two previous cases that I mentioned. And why is that? So it could be because fire engineering is a less mature profession than structural engineering. We haven't been doing this as long. Fire safety engineering failures may be less visible than either aerospace failures or structural engineering failures. And so we don't get feedback. So we can't identify the people who are responsible. And we can't inform the profession. Significant fires are rare. They're not generally publicly interrogated, although with some notable exceptions. And the design feedback loop is therefore weak, unlike the example that I just mentioned in seismic design. So what regulatory expertise is needed for performance-based design? Well, the current situation is that regulators typically continue to evaluate fire safety designs, the AHJs. This increasing use of performance-based design in that context that still perpetuates itself out there raises two questions. One is that some jurisdictions appear to have enabled performance-based design via local negotiation about what level of safety is considered adequate. And I think that should make us all a little bit uncomfortable. Performance is now significantly prescribed in some jurisdictions as a consequence of a recognition that this can happen. So in New Zealand, they've kind of pulled back a bit from performance-based design, and then they now prescribe the manner by which performance-based design can be performed. So they have prescribed performance engineering of fire safety in New Zealand. And the other issue is the approvers might not have sufficient expertise. So the approvers might just not be able to do it. And this is particularly a problem if professional accreditation and competency awareness are weak. If we have weak mechanisms to accredit the people who are approving designs, and if the people who are approving designs aren't competent and aren't aware that they aren't competent, which is a paradox, then we have a problem. And it's crucial that in this context, people not operate or act outside their competencies. So, of course, high levels of professional ethics are critical precisely because of the limits of fire safety knowledge and the need for judgment in its application. And it's necessary, therefore, not to look just at the role of social relations in how fire safety knowledge is used, but how the social affects the way that knowledge is created and verified. I'm really sorry about your lunches here, because it's going to take me a minute or two. So, part 3, how do we generate and apply fire safety knowledge? The first thing to mention is regulatory testing, and I could go on and on and on about fire resistance testing and regulatory testing. In fact, I think I did last time I was here. So if you want to see me talk about that in the context of timber buildings in particular, I think go back and look at that. But much of our fire safety knowledge comes from pragmatic social requirements rather than what Bart and I might consider pure knowledge seeking. So most of our fire testing laboratories around the world are direct products of the regulatory environment that fire safety operates within. So these labs perform standard furnace tests and standard flammability tests and standard other types of tests to achieve certification of products and compliance of products and materials. So these are compliance testing in support of prescriptive requirements rather than trying to understand or generate knowledge. And it's important that we recognize that. Edwin Sachs, so where does that come from? Comes from about 1903. Edwin Sachs, the UK Fire Prevention Committee, basically said at that time, people are using this term fireproof indiscriminately. It doesn't actually mean anything. We need to standardize the way things are tested for the case that might be used. And they ended up developing in 1918 the standard fire resistance test by ASTM. That hasn't changed now in 100 years. Happy birthday to the standard fire resistance test. But it hasn't changed substantially since it was instigated, nor has the framework by which it's used substantially changed. And so we can ask questions about whether or not that's a credible position for us to be in as a community, given that, as Bart has just shown us, the science has advanced massively in the intervening 100 years. So the results of these fire resistance tests are the basis of building regulation and design still, with respect to fire safety. They're central in the history, but they only provide crude measures that we can use to provide fire resistance. And this wasn't actually a problem so long as buildings remain more or less the same with only incremental changes. But the limitations of standard testing actually matter a lot when we do performance-based design for fire. And that's because claims about fundamental fire safety knowledge are used to create engineering solutions with potentially finer margins of safety, so we actually need to know what the unknowns are, and because we have all this innovation going on that might test the limits of this historical evidence that we all sit behind that says everything is all right. So a legitimate concern is that some of the actors involved might take the results of standardized testing to reflect actual performance. And this is a concern that I come up with this concern actually weekly in conversations with people within the fire safety profession. Fire test results have become a useful social convention, being central to the building approvals process, and they get repeated every day, so they take on this credibility and this realism that isn't justified. So two quotes here that I'll let you read if you go back and look at the notes. But in 1970, Harmathy said, these tests aren't real and shouldn't be thought of as real. In 1981, Margaret Law said much the same thing. And yet, people still talk about a 30-minute fire-resisting door being good for 30 minutes in a building. And at 31 minutes, you know you're going to have a problem. So we have to ask questions about whether the test specimens in these fire tests are sufficiently representative of those that are actually going to be used in buildings, either because the manufacturer has given unusual care in running their test, which you couldn't really blame them for, could you? Or because the test design is unrepresentative in some way of how the elements will perform or be constructed in real life. Comparative fire testing of regulatory compliance is undoubtedly going to continue because of the inertia that's in the fire safety community. We can't just stop doing it. We have to continue doing it, or our entire framework falls apart. But it would be less open to misinterpretation if performance levels were rated according to physical behavior rather than minutes. And one of my pleas for everybody in the room is, henceforth, from today forward, please remember that I was here, and never, ever again use 60 minutes or 90 minutes or 120 minutes. Just simply change the word minutes to points in every conversation that you're having, and the fundamental basis of the system becomes clear. Stop using minutes and hours. Just say points, please. And if we all start doing it, everybody will wake up, I hope. And we need to populate the fire safety industry with people who understand that and who understand the fundamental science. And we need also, the last point here, knowledge that is untainted by regulatory requirements. So we also need the kind of work that BART does, and we need it very badly. So, how would we do this differently? By first principles. Traditional fire safety engineering rested typically on empirical observation. David Rasbash, on this day in 1974, interestingly, said that we can't continue to rely on these prescriptive methods and this historical approach to fire safety, and we need science. And he then created the Fire Safety Engineering Group at the Research of Edinburgh, or at the University of Edinburgh, where I now work. So he basically said we need to be knowledge-based about this. And that's great, but it also raises a number of concerns if we increase our theoretical understanding. Do the models that we're using rest on a large number of assumptions that are opaque to people who are unskilled? Are we allowing our models to be used by people who don't necessarily understand how tricky they are? And that is important for a whole host of reasons. One is that realistic large-scale testing of fire safety generally shows that our predictive ability remains severely limited. So every time someone does do a large-scale test of something complicated and they instrument it and they understand what they want to understand, it turns out that we actually can't predict reality very well. I mean, I got that from BART. And that we can only predict very, very simple things still, despite the power of our science and understanding. And the ability to make good judgments about the predictive ability depends on a deep understanding of this underlying science. And the science and technology studies people, they have a specific technical term which is called the uncertainty trough. And the uncertainty trough says that people who know less believe more. Okay, so BART is far less likely to be confident in the output of BART's model than someone who isn't BART, right? And that's deeply worrying in the context of some of this fancy analysis we see being used within the fire safety community. It's something, and it's a thing. Social scientists have been talking about this thing for decades, okay? There are whole books written about the uncertainty trough, and it's a thing, okay? It's a cognitive thing that happens. So we need to be aware of it. And another concern is that these simulations look really good. and they can be deceiving for people. And particularly practitioners and approvers might be impressed without fully understanding all of the knobs that have been turned to make the solution do that thing that they're looking at. So there's a considerable, and the last point is that there's this challenge of predicting how people behave in fire. So on the basis of that, all areas of knowledge that are central to fire safety engineering are characterized by known unknowns, the things that we know we don't know, but also unknown unknowns that we need to be aware of as we progress. So conclusions, sorry, I'm going slightly over my time, I believe. These are kind of the take-home points. None of this is new, you'll be pleased to know. So we're doing really great. We have improved knowledge, better engineering, appropriate regulations, and fire deaths are at their lowest levels in living memory. All is grand. But it's important not to be complacent, and not only because, as I mentioned, many regions around the world are not doing anywhere close to as well as we are doing, and to be perfectly honest, the reasons for that are predominantly social. Shack towns in South Africa, in the Western Cape, do not require technical solutions. They require social solutions. And I think it's disingenuous of us as a community to wash our hands of that issue. So even where deaths are low and where there appears to be little societal demand for improvement, it's important that we are aware of these risks and we check what innovation is doing. And of course, this innovation is happening all the time, and the regulatory processes that we set up to check that innovation can misfire profoundly in ways that I've tried to explain a little bit. So the ideas in the paper and in this presentation seek to unpick the processes by which that happens from the science and technology of knowledge perspective. The application of improved fire safety knowledge and performance-based design approaches, which I think we can't stop from coming even if we wanted to, which I personally don't, poses particular challenges. The first being, can regulators be expected to have sufficient understanding to evaluate these designs? And if the answer to that question is no, then should fire safety engineers effectively self-regulate in the same way that the aerospace or the structural engineering professions do? And how might we do that in a particular national context? And these are important discussions for the profession to have. There's a need for quantifiable knowledge claims about fire safety performance, both so that we can actually stand behind our designs, but I think more importantly, so that we can hold people to account when they don't get it right. And I think there may also be concern if the underlying philosophy of the performance-based design solutions makes people overly confident to be very efficient in their designs and to strip all the fat out of the things that they're doing, perhaps unjustifiably. So what am I really saying? Well, I'm really saying that fire safety needs to be simultaneously more social and less social. More social in that the significance of human behavior for the use and upkeep of fire safety features points to the need for research that considers how buildings are constructed, used, and maintained, and in a manner intended by their designers, but more importantly, to ensure that they're designed in such a way as to make their use and maintenance requirements realistic, given the interactions with fire safety, the social interactions with fire safety. For instance, widespread use of fire doors would be my favorite example. And less social, in that we need a lot of research that is completely unpolluted by the concept of a 60-minute fire resistance period, and doesn't care about a 60-minute fire resistance period, and simply seeks to understand. And we need more of that research as well. Of course, I'd say that I'm an academic. And finally, there's a need to quantify the socially acceptable levels of safety across building types and occupancies, not just for fire, but for all aspects associated with safety. So hopefully you found that slightly interesting. I apologize, I went a bit quickly there at the end. I just want to acknowledge in particular Graham Spinardi at Edinburgh University, whose insights led to most of the bullet points that I put up here today. Jose Terrero, who's a longtime co-conspirator and friend. Lloyd's Register Foundation, who funded a big workshop that we ran that a lot of these ideas fell out of with people from across the fire safety community. And that was held in Gullen, and all the people who participated are shown there. Thanks very much.
Well, Luke, thank you. You said, I make your head spinning, and halfway my head was already spinning. Sorry. So I think I need a 38-page paper of you to just read it at home and let it
please,
come.
Please do, yes.
And but you told some things, and I think it's very important for us as the fire departments in the Netherlands to collect more data, and also to be more secure about our expertise, because we have a lot of experts in our field, and we have to be, especially because also our regulation is changing the next couple of years, so we have to not be afraid about that, but just be sensible. So, and I was very happy that you, at the end, you put this sheet about a little bit less social and a little bit more social. But maybe some of you have some other questions about this long presentation of Luc. And I got rid of my mic because I wasn't very good in throwing, I discovered. But we have a question here.
Yeah, hello. Thank you. My name is Louis Klee from Rockwool. Hello, Lou.
How you doing?
Fine, yeah. Just one question. You showed us the total cost of fires.
Yeah.
1%. What I learned from the insurance industry is that mostly the total cost of fires, including regarding in business interruption, social cost, and environmental cost, are mostly 4 times higher. Is that also included in your quotation? Or
I'd have to go back and check the source reference for that number, which I got from my colleague Dave Rush. But that comes from like the Global Fire Statistics website, I believe.
So I think
it may not.
The direct cost and the 10 million DALIs, are they included?
The 10 million DALIs included in that cost?
Yeah.
I don't know.
Okay.
I don't know. I would have to check.
Okay.
Thank you.
Good
questions, though. Good point.
Well,
I mean, if not, then it only gets more alarming from a number that is already very alarming. Yeah.
Luc, Ricardo is signing to me, so or he's going to give another answer, or he's going to have a question.
Yeah. Thank you for the nice presentation, and I read your article. My attention was drawn to the first sheet where you say that the community should be more reflexive. And I was looking for where in your presentation it was, but probably it was at the before last sheet. And I want to check if my impression, what I understood from that is correct.
Yeah.
So is it correct that I understand that you say that everybody can say he is an expert in fire safety, but nobody knows who is the real expert? So we need maybe more quality system for the experts. And because that is not true at the moment, we better should not step over to the performance-based fire safety because nobody knows how to do it. Is that correct, or is it not correct?
You've managed to be even more pessimistic and negative than I am. No, I mean, I spend a lot of time talking to lawyers at the moment, and they tell me that I mustn't bare my soul when I'm talking to a large crowd. But I mean, to be honest, I believe that the idea of expertise is a myth. An expert is someone who knows what they don't know. Yeah, that's my definition of an expert, is someone who is profoundly aware of their incompetencies. So I'm not saying that we shouldn't do performance-based design. What I'm saying is that everybody who is operating in a performance-based design space needs to fundamentally recognize the cognitive phenomenon of competency awareness. And the cognitive phenomenon of competency awareness says that those people who are incompetent in a particular area tend to overestimate, not underestimate, their competence in that area. And only by virtue of becoming more competent can people recognize their incompetence. Okay, now that's a terrifying way to live. You never will. You just have to keep. You just have to keep trying, and that's all I'm saying. We all must constantly ask ourselves if we have any idea what we're talking about. Yes. Yeah. And I think if we were all, and that's what I mean by reflexive. I think we just need to reflect more on a daily basis about our competencies, and to recognize there's an entire body of social science and psychology research that says there is this cognitive trick that the human mind plays when faced with evaluating its own competence. We're really generous with ourselves. Yeah? And we just need to be aware of that and operate in that context. And if we did, the world would improve.
Maybe this is a very good time to close the morning part before we become all depressive.
But hang on. That's
because I'm very confident that we have very good experts.
But do just let me say, I'm not saying that we don't have experts. I'm saying that we all need to, and I actually think that is it's important to say this, I think that is a really motivating way of living, as opposed to a depressing way of living. Because you always have to keep learning, and learning is wonderful.
Yes, so and that's what we start this congress with this morning, that we said we're here to share the knowledge all together, and when we go home tomorrow, we collected a lot more knowledge, especially when we get the website where we can find your paper, so we can read it at home. I want to thank Marco, Bart and Luc today for their interesting presentations, and I want to thank you all for being such a good listeners and just being such a great audience.